Here we go, page 52 in your notebook. Today we're chapter 3, section 2. It's proof and perpendicular lines. Guys, don't be intimidated by proofs. You are rocking proofs. With your arms, show me perpendicular lines. Let me see them. What does that mean? You got it. You got it. It's page 52. All right, so at the end of class, here's what I'm hoping you will be able to do. Complete a flow proof. Yikes, that's new. We haven't talked about flow proofs yet. We've done 2 column proofs, yuck paragraph proofs, right? Now we'll do the flow proofs. And then also use perpendicular theorems. Guys, I really think you'll rock the perpendicular theorems because they seem logical. You know what perpendicular means. You've learned it. You learned it in elementary. Let's just see how we're going to use them. Okay, the only function is flow proof. Now, yes, I could give you like a paragraph version of it. Let's just do a visual. Flow proof looks like this. Are you ready? Let me grab the pen tool. Flow proof starts with a box. And then underneath that is a line. Okay, so what goes inside the box? Inside the box is your very first statement. Okay, what goes underneath that box? It's the first reason. So you know how we've done that in our 2 column proofs? This is just a different way to look at it. Okay, and then it's flow proof, so it flows somewhere. So then you'll see like an arrow. I'll go to another box and another line. So there will be a box and a line under it. Inside the box, what do you think's in the next box, guys? Yeah, second statement. And then second reason underneath it. And then so on and so forth. Let's not stretch ourselves too far. Again, it's just boxes. It flows somewhere. We have them later on in our notes. You'll see exactly what this means. Okay, what's next? Oh, is it right into the theorems? Okay. Here we go. So theorem 3.1. It says if you have 2 lines that intersect to form a linear pair, stop. What does linear pair mean? Side by side. What else? They're side by side, but what else? Add to it. Allie? Their angles equal 180? Perfect. Guys, what's the geometry vocab word hint that stands for 180? Oh, that's backwards. Supplementary. Perfect. So linear pair, they're supplementary. But it's saying if they intersect to form a linear pair that's congruent, so right here, is this a linear pair? Is it making this line? Yes. Okay, check. It's saying, well, what if these 2 are equal? It's saying they have to be perpendicular. Why? If this is 180 degrees, what does this angle and this angle have to equal? That's why. So I'm hoping that's really logical to you. Saying if you have a linear pair, when you cut it, it creates 2 congruent angles because they have to be 90. Those lines would have to be perpendicular. Okay, the next one says if 2 sides of 2 adjacent acute angles are perpendicular, then the angles are complementary. Check, what do you think? If this one is right next to this one, forms a 90 degree, guys, the complementary stand for 90 degrees. Yes. I think the key in that one, it's a review. Do you remember what adjacent means? Adjacent gets forgotten. Adjacent is literally right next to each other, but they have to share a vertex. Okay, last one, maybe the most obvious of them all. It's saying if 2 lines are perpendicular, then they form how many right angles? Does that make sense? It would have to all be right angles, right? You've got linear pair in there, you've got vertical angles in there, they all equal 90 degrees. Okay, heads up, the next page, yikes, it's one proof presented 3 different ways. It's presented first in a 2 column proof, and then in a paragraph proof, and then on our flow proof. Ooh, bless you. Let's start with the 2 column proof. We're used to that. Let's use our logic reasons. We love when they give us stuff because we can use it to decide what goes where. Okay, here we go. So what are we trying to prove? We're trying to prove measure of angle AB equals measure of angle DEC. And we'll get there eventually. Let's just follow it and use all of these reasons as major hints. So the very first one, the reason, guess what is it? It's given, so let's go right up to the given. Right here, that's our clue. So measure of angle AEC. Shout out, guys, what is it? Yay! Perfect. DEB. Done! We can at least get that much in there, right? Okay, so that first part is given. Our next part, here's our hint. Our hint is angle addition postulate. Because we've done lots more with segment addition postulate, but it's the same thing. It's like you're breaking an angle into 2 pieces. So check it. Use your picture. I keep begging you to draw on your books, on your tests, on your quizzes. Highlight it. Here's AEB. AEB plus something is going to equal AEC, this one. What are we missing to get that bigger angle? Which angle are we missing? Perfect, BEC is what we're missing. So right here, let's just fill it in. So if we add those two together, we'll get the big angle AEC. Okay, number 3, our hint is substitution. We'll look at number 2 compared to number 3. Number 2, measure of angle AEB, measure of angle AEB. Nothing changed. Measure of angle BEC, measure of angle BEC. Nothing changed. This has got to change if we're going to substitute. So that's saying take out measure of angle AEC and put in, do you know what we can put in? Yes, DEB right from number 1. This is these two are equal, so we can interchange them. We can substitute. So let's keep it with angle DEB. Nice. Okay, number 4, angle addition postulate. I want you to think about this one before we do it together. Remember, angle addition postulate, go to the picture. Go to the picture and see what those two angles added together equal. Which angle is it? Okay, so I'm hoping you're highlighting your books, or at least pretend tracing. So you've got DEC and what? BEC? Okay, shout out what angle, those two added together, what angle does it equal? BED. Yes, BED. Are you okay if I just call it DEB to keep going with the same proof? Same thing, so it's still DEB. Yikes, here comes number 5. Number 5, transitive property. You guys are pretty dang good with this when it comes to algebra or like a sentence where we can take stuff out. Be careful with this, guys. They're looking at number 3 and number 4 together and using the transitive property. What do they both equal so you can take it out? Do you see it? Yes, look, right here. Good job, Kelly. You can take out measure of angle DEB. They both equal this. So take it out and set these two equal to each other. That's what transitive property is. As long as they equal the same thing, we can set them equal to each other. So right here, measure of angle AEB plus the measure of angle BEC is going to equal the measure of angle DEC. I'm just copying this down. Plus the measure of angle BEC. One more and we're done. Okay, if this was more linear, side by side, I think you would see it a lot faster. How come we can jump to this conclusion? Measure of angle AEB equals measure of angle BEC. Oh, look at all these hands. Guys, good job. Tyler, what do you think? Subtraction property, is that what you said? Transitive property, not quite. Transitive property means they both have to equal the exact same thing. We've only got one equal sign in here. What you guys were going to say? Allie, what do you think? What are you subtracting out of there, Allie? Yes. Take this out. Take this out by subtraction. You can set those two equal. If it was algebra, you guys would have rocked that. Just kind of hard when it's this vocab, right? Good job, Allie. So that would be subtraction property. Good try, Tyler. Definitely good try. Woo. Okay, we kind of blazed through that proof, but thumbs up, have these sideways, have these up, sideways, or down. How do you feel about that proof? Were those clues helpful to you? Okay, put your pencils down. Put your pens down. Do not copy this next part. I know you are so tempted and you are so trained to copy down anything a teacher puts up here. I just want you to look, okay? You don't have to copy this down. Ready? This next part, let me clear this. Okay, finished it, right? This part, what I'm going to show you is in paragraph. So we've already finished it. Same thing in paragraph 4. How many of you, I don't mind paragraph 4. How many of you don't love paragraph 4? It confuses me. I think it's too much at once to look at. Okay, new proof. So this is what we just did in a different version. This is what a flow proof looks like. Again, don't worry about copying this down. We'll do one later. The reasons are in boxes. Excuse me. The statements are in boxes. The reasons underneath them. It's the exact same thing. Nod your heads, yeah? Do you see it? Okay, let's do our own. I think the next part of our notes is a flow proof. Is it? Top of the next page. It is. Okay, let's do this one together. We'll be all right. It's still nice because there's still clues to go from one thing to the next thing. So here we go. Here's our very first statement. Ray BA is perpendicular to ray BC. What's your first reason? Where did that come from? Get in. So nice. Okay, well, look at your picture because then it jumps to some angle in that picture is a right angle. Guys, shout out which angle is a right angle. Yay, ABC. Good job. So fill it in, ABC. That's because you know what perpendicular stands for. That's definition of perpendicular lines. Okay, well then the flow proof is telling you go over here. Over here, what's the measured angle ABC then if it's a right angle? 90 degrees, there you go. That's just because you know what a right angle stands for. That's the definition of a right angle. Okay, let's go to the right. Right here, do you know where this came from? It says measured angle ABC equals this angle plus this angle. Measured angle 1 plus measured angle 2. Do you know why? What do you think? Yes, which angle of postulate? You're missing one key word. Yeah, angle addition postulate. Add the two angles together, it'll equal the big angle. So right here, angle addition postulate. Be careful with that. I see a lot of like segment addition postulates on these ones. Make sure you know what picture you're looking at. Okay, substitution property. This one said measure of angle ABC is measure of angle 1 plus measure of angle 2. We'll check it. We still have measure of angle 1. We still have plus measure of angle 2. Substitute something right here. Good job, guys. 90 degrees. Perfect. Okay, well it's saying if angle 1 plus angle 2 equals 90 degrees, then they're complementary. But why can we say that? Ellie, do you know why?
Well, because they're
Yes, yes, yes. So literally, guys, you know what complementary stands for. So I learned quickly in geometry when I was doing crazy proofs. If I didn't know one of them, I was like, I'm not sure, I always put definition of something. So this one put definition of complementary. You know what complementary means. Default to a definition. So definition of complementary angles. Good job. Okay, our very first flow proof. How you feeling? Thumbs up? Does that make sense to you? How these? I'm doing okay. Now I'm so confused. How you feeling? Let me see those thumbs. Okay, take it. Let's do another one. Okay, this one we've got reasons missing, we've got statements missing. Okay, here we go. This one, as I look at it, I think, yikes. Here's a given and here's a given. So that tells me go up to the given. It looks like we've got to split this into two pieces. But I bet it kind of matters which one goes where. Any ideas which one goes here? Hint, hint, hint. Follow the flow proof. Look what's right here. Linear pair postulate. So we want something right here that will eventually get us to linear pair postulate. So which part do you think we should put right here? Shout it out, guys.
1 and 2 are right.
Yes, right in the box. Okay, so we've got angle 1 and angle 2 are a linear pair right here in our first statement. Okay, so let's put that other given right here. J is perpendicular to K. Okay, right here. Okay, so linear pair postulate hasn't come up too much yet. I think it was on one question on the review for the last test. Linear pair postulate is just saying, do you know what's going on with the angles when they're a linear pair? So check, they're next to each other. They form 180 degrees. But guys, what's the vocab word in geometry for 180 degrees? Supplementary. That's what linear pair postulate is. So we can just say angle 1 and angle 2 are supplementary. That's linear pair postulate. Okay, let's keep going down. We'll go to the other side in a second. Well, if you know that they're supplementary, add them together and what should they equal? There you go. That's because you know what supplementary means. Good job. Okay, let's jump to this side. If J is perpendicular to K, it says angle 1 is a right angle. Why? Why would angle 1 be a right angle? Colton, what do you think?
Because it has a box right there.
Totally. It has the box right there. Why does it form that though? I'd say it's because you know this word. So default to what? What are you going to put? It's perfect, guys. Definition of perpendicular lines. Or angles. Let's just put definition of perpendicular. Okay, well if angle 1 is a right angle, what does it equal?
180 degrees.
Wait, what is it? There you go, 90 degrees. That's because you know what right angles are. Oh man, substitution property. Here we go. So let's rewrite this one. looks like this box matches this box, so measure of angle 1, let's substitute something right there. What can we put right there? 90 degrees, so substitute. So let's keep this measure of angle 2 the same, and that 180 the same. So all we did was replace that, measure of angle 1 with 90 degrees. Okay, this is now algebra skills. What would you subtract from both sides? 90 degrees, so what are you left with? Measure angle 2 equals 90 degrees. So therefore, angle 2 is a right angle of what? Okay, I heard definition of perpendicular. I heard definition of right angles.
Definition of complementary.
Definition of complementary. I don't know which one.
No, it's right angle. You can tell me.
I would say definition of right angles is the best default. Just go with right what's in there. Definition of right angles. Guys, I'm impressed. Good job. Super good. Oh man, are we done already?